Hello everyone. In this session, I would like to share with you our experiences of migrating our SAP systems to the cloud. Sunil and I will be co-presenting today. My name is Om Singh. I am the Senior Director of Enterprise Business Solutions at Newmont. I joined Newmont in 2016 to start the EA practice. Recently, I have taken on the responsibility of enterprise business applications. As part of that ownership, I led the cloud migration of our SAP environment to AWS, which is what we are going to talk about today. I'll start by giving you a high-level background and some of the challenges that led us to the start of this journey. I will then get into our SAP strategy and how cloud migration provided us with a strong foundation that helped us kickstart our SAP roadmap. We will look at why we selected AWS and the different criteria that led us to this decision. We will also get into some of the details related to the migration scope and the various options we evaluated and socialized with our leadership team. Sunil will cover the migration methodology and the high-level migration plan. We will also go into lessons learned that will hopefully give you some tips and data points you can take into account when planning your migration activities. So a little bit about Newmont. Newmont was founded in 1921 and we have been publicly traded since 1925. We are a mining company primarily focused on the production and exploration of gold. We also produce copper, silver, zinc, and lead. We are the world's leading gold company, and our world-class portfolio of assets is based in favorable jurisdictions in North America, Australia, South America, and Africa. We have the largest gold reserve base in the industry. At Newmont, our purpose is to create value and improve lives through sustainable and responsible mining. We are the only gold company listed in the S&P 500 index. Mining is an energy-intensive business. Around 88% of our energy used for mining and milling is generated from carbon-based fuels. It is our responsibility to take care of resources provided to us. We are recognized for our environment, social, and governance practices. Using science-based criteria, we have set climate targets for 2021 to 2030 for our operating sites. We have targeted 30% reductions in greenhouse gas emissions by 2030, with the goal of achieving zero net carbon emissions by 2050. So we acquired Goldcorp in the beginning of 2019. It was a very large acquisition for us, and we are expected to deliver an estimated $500 million of annual cash flow improvements. From an IT perspective, the challenge in front of us was to bring the two environments together. And that challenge created lots of opportunities for us. We started different initiatives for consolidating cyber, network, infrastructure, Active Directory, and application domains. In the application domain, SAP presented the greatest opportunity for us. The SAP systems in the two environments were almost 95% similar, and altogether there were around 150 SAP systems that we had to rationalize. So there was a lot of redundancy, and we had different processes for managing the two SAP environments. Transports were managed differently, testing processes, monitoring processes, KPIs, and SLAs were all different. There were also two support teams with the same skill sets managing these environments, which resulted in a lot of IT overhead. We had a new CIO who had joined from former Goldcorp at that time, and under his leadership, we had clear direction to get out of the infrastructure and data center business. In order to get our arms around the complexity, we created a 5-year roadmap, that would result in both environments merging into a single instance of S4 HANA. The first step in that 5-year journey was to migrate the two environments to the cloud. As we were putting the 5-year roadmap together, we looked at several options on how to approach it. An important decision for us was to figure out whether we will be doing a greenfield implementation or a brownfield implementation of S4 HANA. If we do the brownfield implementation, we can either do a lift and shift to the cloud and then upgrade our systems and then look at optimization opportunities, or we could optimize our environment by reducing the ECC footprint and then upgrade our ECC systems. Both approaches has its pros and cons. One gets us to S4 HANA faster. The latter is slow, but allows us to optimize the environment and reduce the complexity of the migration. The third option was to start fresh, still reduce the footprint to eliminate the complexity and then standardize with a greenfield implementation. This is the longest path, but it allows us to eliminate customizations and adopt standard out of the box functionality. So, on this slide, I want to get into a little bit more into the details on the different options that we were looking at. So even though the options are centered around the core ECC platform on this slide, we also had to account for a lot of peripheral systems like Solution Manager, GRC, SRM, CLM, PIPO, BPC, etc. Our starting point was the two ECC systems which were on different enhancement packs. So on the left-hand side of the slide, you can see the former Newmont ECC on Enhancement Pack 6 and former Goldcorp on Enhancement Pack 8. Option 1 was split into two steps. The first step was to migrate to the cloud, and we could do it in 4 different ways as shown in the middle box. We could do a lift and shift to the cloud, or we could migrate to cloud and upgrade them to be on the same version, or we could upgrade them and put them in one instance with 2 clients, or we could upgrade them to S4 in compatibility mode, which essentially allows us to run it as an Enhancement Pack 8 system on an S4 platform. The second step in option 1 was to then do a client merge into one instance of S4 brownfield implementation. Option 2 was to reduce the footprint by archiving unnecessary data out of the system, migrate financials to central finance, HR, payroll, and learning management to Employee Central, migrate source to contract and procure to pay to Ariba solution, which is the in our terms it's called the request to purchase optimization project, and manage master data using MDG. This would drastically reduce our ECC footprint, and whatever remains, we do a client merge into one instance of S4. Option 3 was to implement a greenfield instance of S4. But before we do that, we had to reduce the existing footprint using the same technologies mentioned in option number 2. So we discussed these options back and forth with several stakeholders, and the general consensus was to take a hybrid approach by first migrating the systems to the cloud and upgrading them to be on the same release. This would give us synergies in terms of resource allocations and operational processes to manage the two environments with a single technical team. Co-locating these environments also gave us the flexibility to consolidate a lot of the peripheral systems like Solution Manager, GRC, PIPO, portals, and BPC. The second step was then to migrate to one instance of S4 using a greenfield approach. As we go along this journey, we will be evaluating and validating these steps and making changes as and when necessary based on the lessons that we learn throughout this journey. The next step in our journey was to select the implementation partner. We looked at different cloud providers and shortlisted Azure, AWS, and GCP. We set up initial workshops with the vendors to help them understand the scope of what we are doing. We had whiteboarding sessions with them, which gave us a good sense of the SAP experience they brought to the table. We also validated this experience with customer reference calls with other customers in the industry vertical. The vendors showcased their migration methodologies and accelerators that could help us get us a head start in certain areas. Automation and optimization of the environment was also very important to us for an ongoing sustainment. We also wanted to get visibility into what kinds of innovations the cloud vendors have introduced in the past and their future roadmaps that could benefit us in the optimizing and automating of our operational processes. We also wanted to make sure that we retained the same SLAs that we had on-premise. So reliability was another important decision for us. When we talk to customers on our reference calls, we try to find out what kind of service they were getting from the different cloud providers and how they were helping them in getting the most out of their environment. After several rounds of evaluation, we selected AWS primarily for the SAP expertise we saw in the implementation team, very positive customer reference calls, and the innovation potential that we could leverage by utilizing a wide range of services to effectively manage our environment. Sunil, who is co-presenting with me, was also part of the AWS implementation team that we talked to, and I was impressed by his expertise and knowledge in SAP technical areas. Another important point to add is that this was not a simple lift and shift migration for us. We not only upgraded the ECC application from Enhancement Pack 6 to Enhancement Pack 8, we also upgraded portals to version 7.5, implemented HR support packs for payroll compliance, upgraded the open text environment, migrated the databases from Oracle to HANA, changed the OS layer from AIX to Red Hat Linux, implemented HA and DR, standardized our backup from Commvault and eVault to the AWS backend solution, set up firewalls, set up the connectivity. What added to the complexity was the fact that we had to add several items to our scope since both the environments were technically so different. We had to re-architect the environment to reduce the complexity that existed in the on-prem environment. And what resulted was a standardization of the environment that was much simpler to manage and upgrade going forward. Our on-premise model was to buy and not to lease hardware. So because of this, we had to go through a hardware renewal cycle every 3 years. This resulted in these peaks and valleys of spend cycles, with different sets of hardware going live, going out of life at different periods of time. It was a constant round robin of capital spend every year, and the infrastructure and application teams were continuously upgrading hardware and testing software. Moving to the cloud helped us avoid these peaks and valleys and allowed us to better predict our spend on a yearly basis. Co-locating both the environments also provided us with the opportunity to consolidate a lot of the peripheral systems around SAP, like moving 2 GRC systems into 1 GRC system, 2 PIPO platforms into 1 PIPO platform, and consolidating solution manager and portals. We eliminated significant backup costs by using the standard AWS backend solutions. Storage costs were significantly reduced by using the S3 storage compared to tier 1 storage in the on-premise environment. Expensive AIX frames were replaced with EC2 instances. Optimization and standardization of the cloud infrastructure combined with automation helped us to achieve an operational cost reduction of around $530K per year compared to our on-premise spend. The other pain point in our on-premise system was the absence of DR. With the move to the cloud, we set up a DR infrastructure in the cloud, and we defined our RTOs and RPOs, and we were able to provide a more reliable and resilient environment to our business. For strong security posture, we built brand new Palo Alto firewalls. There were a lot of band-aids that we had put in our on-premise environment that we were able to eliminate since we had to re-architect the entire network infrastructure as we move to the cloud. And the other point is that consolidating solution manager into one instance also provided us with a single point from where we could monitor our technical landscape. And it also allowed us to implement a consistent transport mechanism for change management. So as we were ramping up our production waves, we had two major events. So COVID hit us in the beginning of March, and we were all asked to work from home. As we progressed through the waves, our scope started becoming broader and more complex in scope, and COVID started to worsen. We had to account for people working remotely, dialing in via VPNs, dealing with connectivity and other technology-related issues. We had to improvise with the new way of working. We had to deal with more WebEx meetings, managing work-life balance, and with a lot of meetings in our calendar, it was very hard to manage our day-to-day work schedule. One good thing about it was it helped us to become more inclusive and work around with everyone's schedules, and also at home with kids running around and everyone sharing the same bandwidth. In addition to that, we also had a cyber event that we dealt with for 3 to 4 weeks. And sometimes during the cyber event, we had to shut down our entire SAP systems to minimize the impact of our environment. In some cases, people had to physically go to the data centers and plug and unplug hardware from there. We had to restore certain systems from our backups. It disrupted our migration but we put in extra hours to help us catch up on lost time. Our partners, IBM, Infosys, AWS, and the internal teams were very flexible and understanding during these tough times. So, going forward, Sunil will cover the rest of the slides and go into the details of the migration plan, methodologies, and the architecture.
Thank you, Om, for sharing the details of your cloud journey. So far, we already learned about challenges, scope of migration work, and the benefits. For the rest of this session, I'll walk you through high-level project plan, migration methodology, and lessons learned. I also wanted to cover the technical architecture, but that's a lot to cover in this 30-minute session. Hello everyone, myself Sunil Yadav. I'm Principal Consultant at AWS Professional Services, Global SAP Specialty Practice. My role in this migration was that of a technical lead architect from AWS Professional Services side. For the entire duration of this project, I had the opportunity to work with very talented and capable architects, consultants, administrators, and project managers from Newmont, Goldcorp, AWS, and our other partners. Our teamwork and collaboration made this complex project look easier, and we were able to go live under budget and ahead of our original schedule. I'll first cover the high-level project plan. We call it migration plan on a page. We started with the assessment and discovery back in August 2019, followed by the mobilize and planning phase. I'll cover these in detail in next slide, but here I would like to explain our migration wave strategy. As Om explained earlier, both Newmont and Goldcorp have identical set of SAP systems, with one key difference being that most of the Goldcorp's SAP systems were already running on HANA, and whereas Newmont has to go through a technical replatforming from their AIX Oracle to Red Hat SAP HANA. Also, Goldcorp systems were in two different data centers across Canada, whereas Newmont systems were in Denver, USA, a single data center. Essentially, these were two different cloud migration projects embedded into one. Hence, we plan to migrate these two in two different waves. With further refinements, we divided each of these waves into two waves. Wave 1 had all non-critical Goldcorp systems, followed by all critical systems of Goldcorp in Wave 2. Similarly, in Wave 3, we had non-critical systems of Newmont, and Wave 4 had all the critical systems, including the ECC, where we have to apply HRSP upgrade and conversion to HANA using SAP some DMO run. The first key benefit of using this approach was to reduce the risk, as we were able to validate the migration approach and AWS landing zone with less critical systems. Second benefit was that they were able to reduce the number of project resources, primarily the SAP basis resources, needed during the production wave cutover. In addition, this approach allowed us to focus on Goldcorp migration while we were still prototyping for Newmont's ECC conversion to Suite on HANA. We finished migrating all Goldcorp systems by mid-April, around April 20th, and all Newmont systems by June 2020, ahead of our July target, which we now use for hypercare and transition of systems to production support team. Now let's go into the details of some of these key phases. Okay, so we're going to start with the assessment phase. And in our migration methodology, we divided into four key phases. The assessment phase was the first one. Here we focus on the assessment and discovery of Newmont and Goldcorp's current infrastructure setup and requirements. In the early stages of the project, AWS team conducted a series of workshops, verified the SAP systems which were in scope for the migration, and filled any requirement gaps. By the end of this phase, we were ready with high-level migration plan, architectural concepts, and objectives like RTO, RPO, high availability requirements, DR requirements, along with the draft landing zone. This really allowed us to speed up the work in the mobilize phase. So in the mobilize phase, we refined the project plan and architecture further. And we also completed the blueprinting for Newmont's target SAP on AWS architecture. We implemented our landing zone using control tower and set up 3 separate accounts for SAP development, SAP QA, and SAP production, followed by the migration of sandbox systems as a proof of concept, which built the foundation for the migration execution. In this phase, we also mapped the source infrastructure to AWS services and started the work on direct connectivity from on-premises to AWS regions. During this phase, the majority of the migration team was also onboarded and briefed for the migration execution. In particular, one of the most time-consuming activities, which is the direct connect setup. So we should plan early and get a head start on that because it could take few months. Now let's move on to the mass migration phase. In this phase, we migrated all the remaining systems from dev through production. As discussed earlier, we started the migration of Goldcorp and Newmont systems in 4 waves of production. But migration of non-production systems, we used Big Bang approach, where we migrated all Goldcorp dev systems in single wave and all Newmont dev systems in another wave. We followed the same approach for the QA systems as well. For the technical migration, we used SAP native tools like Software Provisioning Manager, some DMO with System Move, and HANA system replication, as we were able to secure sufficient business downtime. So we do not have to use any specialty tools to reduce the migration. Apart from the migration of the systems, we also completed other critical tasks like setup and scheduling of backups, high availability setup, disaster recovery testing, and as the systems were getting migrated, we were able to complete each of these tasks for each of those systems which were getting migrated. So a lot of this work happened in parallel as we worked through the migration. Our next phase was the optimize phase. This is where we covered the continuous process improvement for the infrastructure lifecycle and ensure infrastructure security compliance is met. Further infrastructure automation, system fine-tuning, and AWS best practices targeting operations were implemented together with our go live review reports prior to cutover of every wave. So this go live check is different from what SAP executes. This is a custom go live review check designed by our AWS specialist, and this is focused on making sure that there are no gaps when you migrate your critical systems. Though this phase is marked as a post-migration phase, we actually started on this as soon as the first workload was migrated to AWS. We leverage our newly released service AWS backend for HANA backups to S3, and we also build CloudWatch dashboards for monitoring of custom SAP metrics like SAP HANA used memory. So some of these services allowed us to look further into how these systems are behaving and capture those details. Let's go on to the next slide. So this is the final end state after we completed the migrations. So as previously, Om has covered various changes we did during the migrating systems from Newmont and Goldcorp. During migration, we migrated about 76 SAP systems from Newmont's Denver data center, 55 systems from Goldcorp's Markham data center near Toronto, and 19 systems from Goldcorp's Calgary data center in Alberta, Canada. We had 2 identical systems for each of these applications shown, with the exception of Solution Manager, which we consolidated, and now we had only one Solution Manager serving all the systems. But now these applications are standardized. They're running on same operating system. Most are running on HANA databases, and they have a similar architecture from high availability perspective also. As Om shared, the effort is underway to consolidate and eliminate some of these applications as Newmont gets closer to the single S4HANA instance in the coming years. Okay, now let's go through some learnings from Newmont's migration. So I'll start with the storage costs. When pricing the storage cost, most often the focus is on the storage attached to EC2 instances like EC2 block store and elastic file systems. However, please make sure that you include S3 storage costs for backups. The cost varies depending upon the frequency of backups, size of backups, and retention policy. We should leverage Amazon S3 Glacier for backups having longer retention period to keep the storage cost low. The next one is to engage the right stakeholders early on, in particular your security and compliance teams. This will speed up the decision making, reduce risk, and potential rework down the path. For example, before diving into the design phase, identify the contexts will help define the security and compliance requirement which must be met. For example, ingress and egress traffic, packet inspections, country-specific data residency requirements, and the minimum duration to retain certain backups. Next one is to have your requirements drive the design. So what we noticed is that with so many options available, the team gets excited and everyone wants to build the best architecture in cloud. Uh, and of course, we are adding this as a learning as cloud provides a lot of flexibility and simplicity in improving the application architecture, in particular for the HA and DR. So everyone would like to have a design which provides near zero RTO and RPO for both HA and DR. However, there are no extra points for driving the cost higher. So we should pick the right architecture and make sure that it aligns with our requirements. Hence, it's important to map the design decisions back to the original requirements. The next one is to dive deep for replatforming impacts. So most of these complex migrations where you're changing your operating system and your database, so you have to look into some of those impacts to your tools, your scripts, your configurations which are platform specific. So you need to dive deep and revisit these tools and configuration to see if these are still relevant for target state. Also identify if any tool scripts need to be re-implemented on a new systems. Some examples are OS code page changes, SAP profile parameters, backup scripts, and monitoring tools. Om had already covered in detail the impact we had from COVID-19 and cyber attacks on on-prem systems. Our design for migrating SAP systems to AWS was completed much ahead of any of those COVID-19 impacts. And from day one, we had kept security of application and data as our prime focus. A secure design and proactive approach towards security in cloud allowed us to continue running the SAP applications on AWS cloud securely. So the learning is if you keep doing work towards the security right from start, then there's no heavy lifting to be done towards the end of the project. So no shortcuts. Finally, the last learning is a reminder that while there's a lot of focus on transactional data which lives in databases, there are also many important files which reside outside the SAP database. For example, SAP transports, configuration files, encryption keys for secure storage file systems, batch job logs, and previously processed flat files in interface directories. Hence, review your requirements and plan to migrate these files as well if required. Most of these files are static, so bulk transfer can be completed prior to final cutover, followed by a final sync of these files during the cutover window. For example, if you're migrating from a Unix or Linux platform to another Linux platform, you can make use of a handy utility called rsync, which is what we use in our project. Okay, so next we have a quote from the CIO of Newmont highlighting the importance of this migration to cloud in their journey towards single global instance of HANA. Thanks, Lois. Okay, so now we are coming towards the end of this session, and here's a summary of other breakout sessions relevant for SAP customers and our partners. Refer to the session catalog for more details. That's all we wanted to share today. So on behalf of Om and myself, I'd like to thank you all for joining this breakout session. I hope this information helps you in your respective cloud journeys. And by now, if you attended other breakout sessions, you must know that AWS loves your feedback. So please help to complete this survey. Your feedback is valuable. Thank you very much.